Okay, we're going to do general proofs of quadrilaterals. Okay, this is our first little introduction to proofs. So the first thing we're going to do is I am going to build a parallelogram right off to the side. Okay, so I need you to follow along with me for that. So I'm going to draw a little XY axis right here. Here's Y, here's X, and we're going to build a general parallelogram. Okay, it's going to look kind of weird. Okay, so I'm going to make a parallelogram with no numbers. We don't know what, I know there's little tick marks there, but we don't know if they're counting by ones, by twos, by 1/2, by 0.5, by 0.6. We don't know. So I'm going to draw in here a parallelogram. So it looks like this. And I'm going to label these sides. This is going to be M. This is going to be I, T, and E. And then I'm going to give you some weird points. I'm going to tell you right here, this dot right here, this purple dot that I'm drawing in, is A, comma, 0. E is at B, comma, 0. What would M be at, though? That should be pretty straightforward. M, as in Moore or Murphy. M is at what point?
0, 0.
Good. Okay, now to figure out I and T. This point right here, I'm going to call this 0C. All right, so I know that M is at 0, 0. E is at B, comma, 0. What would I be at? I went over how much, up how much? I went over, do you guys see this in purple?
3.
Not 3, but,
4.
nope. Why are we counting? Remember I told you, I don't know if they're counted by 1s, 2s, 0.5s, 0.6. What is this letter right here? A. Okay, so I went over A and I went up how much? C. Okay. I know it's weird. It'll get better. All right, and then T. I went over B and then 1, 2, 3 tick marks more. How many tick marks is A? 3. So I'm going to go call it B plus A. I know it's weird. Okay, then tell me instead of saying she's got to slow down. Actually say Miss Murphy slow down. Okay, and how much did I go up? C. Okay, so now all I'm going to do, guys, is I'm going to rewrite. I'm going to write M and what the coordinates are, E what the coordinates are. Does that make sense? So I'm going to go like this. M is 0, 0. What's E? B, 0. What is I? AC. And then what is T? So, now I've got those coordinates. Now I'm going to have to find the lengths and the slopes of each side in order to talk about that it's a parallelogram, right? We know opposite slopes should be equal. We know opposite sides should be equal, okay? So, I'm going to go through. I'm going to go on this side. I'm going to talk about length. And we know length is like the distance formula. So that's the square root of x1 minus x2 squared plus y1 minus y2 squared. And this one is slope. We know that's y2 minus y1 over x2 minus x1, right? So far, so good? No, because I gave you weird letters instead of numbers. Length is the square root of x1 minus x2 squared plus y1 minus y2 squared. And slope is y2 minus y1 over x2 minus x1. Okay, I'm going to find the distance from M to E, and then we're going to find the slope from M to E. Okay? All right. M to E. Now, I can put this in the distance formula, or this is a horizontal line, correct? So, did I go up at all from M to E? No, I just went over. How much did I go over? B. So that is the length of M to E. It's just B. And we'll do one where we have to do it with distance formula. But let's talk about the slope. Did I go up at all?
No.
So that's 0. And then I went over B, right? So 0 over B gives me the answer is 0. If 0 is on the bottom, what do we call it? Undefined. Okay. Now we're going to do what? You're good? Okay. Now we're going to do E to T. Now E to T isn't as clear, right? It's kind of on a slant. So we're going to have to do the distance formula. So I'm looking right here at E and T. I'm going to take x, which is b, x1 minus x2, b plus a, squared, plus 0 minus c squared. Do you guys see that I just made like this x1, y1, x2, y2, and plugged it into the formula?
B minus what?
B minus b plus a squared. All right, b minus b disappears, right? So are we okay with that we just end up with a squared underneath the square root sign?
No.
What's b? Take away b is just 0, right? 0 plus a is just a.
What happened to the? Okay.
What's on the outer end of that one?
Is the answer just a squared?
0, no.
The 0 minus 6?
This is b minus b
Yeah, no, the other one.
plus a squared plus 0 minus c
Oh.
squared. Okay. What is 0 minus c?
C.
C. So plus c squared. That's my answer. I'm done. Okay.
What's the answer?
Square root of a squared plus c squared. Okay. We're going to do the slope from E to T. So we're at E. We're going to go T. I went up C. Right? Let's just put it in the formula. E to T. So I'm going to go C minus 0 over B plus A minus B. I get C over A.
What is that?
C minus 0 over B plus A minus B. C over A is my answer. Okay. Now we're going to do, we did E to T. Now we're going to do I to T. To go from I to T, we're going to put it in the distance formula again, because we need practice for that, I think. So we're looking at I and T right here. So I'm going to go A minus B plus A squared plus C minus C squared. What's A minus B plus A?
B.
Hold on, am I doing this right? I to T, I just end up with B squared, right? And then C minus C is 0. What's the square root of B squared?
B.
B. Look, they're the same. That's what I wanted. Now we're going to do the slope. C minus C over A minus B plus A. C minus C is what? 0. So if there's a 0 on top, I know the whole thing is 0, and I can just stop, right?
Yeah.
Okay. Now we're gonna go and over here, because I don't have enough room, because Miss Murphy's handwriting is too big, we're going to do I to M. Okay, I to M. First, we're going to do the distance formula. I'm looking at I and M, so I'm going to go 0 minus A squared plus 0 minus C squared. And I end up with the square root of, what's 0 minus A? A. So I get A squared. Am I going too fast? Okay. And then what's 0 minus C? C. So we get plus C squared. Okay. Now I'm going to do the slope of I to M. So I'm going to go C minus 0 over A minus 0 gives me C over A, right? See how these two are the same? These two are the same. These are the same. These are the same. I know it's weird, but we got it, right? Okay. Define the term segment bisector. If it's a segment bisector, then what? What does segment bisector mean? A segment is a line and a bisector cuts it in half. Then it cuts the segment in half. Okay, we're going to write this as a biconditional statement. It is a segment bisector if and only if it cuts the segment in half. So far, so good? Mm-hmm. How are we doing? Can I keep going? Give you a second. All right. Now we need to talk about the diagonals. So we're going to talk about from M to T and from E to I, and we're going to find that they bisect each other. So we're going to use what formula again? From your quiz yesterday, what formula tells you that they bisect? Not Pythagorean theorem, but midpoint. Good. So M, I'm going to write down, M is 0, 0. T is B plus A, comma C. Okay, we're going to use the midpoint formula. Who remembers what that is? Anyone? Y1 plus Y2 over 2. That's my X1, Y1, X2, Y2. How are we feeling about that? Okay, so X is 0 plus B plus A divided by 2, and 0 plus C divided by 2. So you just get B plus A over 2, comma, C over 2. We want I to E's midpoint to be the same thing. So why don't you guys try it on your own for just a second. I to E is B comma 0, and I is A comma C. See if you can use that to do the midpoint formula right now.
Did I say A for C?
B.
Oh no, I'm next to video.
This is B0 AC. Yes.
Oh.
I know. Good. So we did b plus a over 2
Yes.
and 0 plus c over 2. So we get b plus a over 2, comma, c plus c over 2, excuse me. So they're the same, right? So that proves that they bisect each other. Okay, I'm going to set up the back with you. I'm going to set up the back. I want to draw I don't want you to be doing this on your own yet. But I'm going to give the rest for you to work on in class or for homework. So I want you to follow along. Okay, what I'm going to do for you is I'm going to set up the picture and what the coordinates are, and then I'm going to let you guys work on your own. You ready? Here's the y-axis, here's the x-axis. Okay, and then I'm going to call this E, F, G, H, and I'm going to say that this is a square. Okay, so I want to talk about what the coordinates are for each of these. What is the coordinates for E? What would E have to be? 0, 0. Okay, so I know this is 0, 0 right here. So far, so good? Okay, now I want F.
0.
So we could call it 0A, that's fine. Yeah, I can slow down a touch.
Why can't you put
Wait,
no?
can you
So the problem with 0F, okay, what do we know about squares? All the what have to be the same? And all the sides, all the lengths have to be the same. So if F is 0A, then H has to be
0, 0.
not 0, 0. 0, 0 is E.
B zero.
No.
A zero.
A0. So you don't want to put F because then H is F0. You know what I'm saying? Like you want a different letter. Okay. So what is G? I went over AA. Okay. So you're going to have to find all the lengths of the sides, all the slopes of the sides. So I like to draw a line down the middle and be like, these are my lengths, these are my slopes, okay? And I'm going to go E to F, F to G, G to H, and H to E. Okay, I think you guys can define congruent segments and make a biconditional statement. If we're talking about diagonals, the diagonals you need to find are the lengths of E to G and the lengths of F to H. I think you guys know what perpendicular means and are able to do that, but you also have to find the slopes of E to G and F to H. These are lengths, which I cannot spell apparently, and these are slopes. Okay? And I will walk around and help. Okay? I would like to at least get you started on some of these before you have to do them for homework, but we've got a decent amount of time left in class, so we should be able to do this. All right, I am going to stop recording.